Welcome once again to Prismatis online class. In this class, we are going to study what? Uh, our topic, complex number. In our previous class, we gave a definition of what complex number is all about, the application of what complex number. We still say that complex number is defined as a summation of real parts denoted by RIMZ and pure imaginary denoted by IMZ. That is the complex number. Addition of what? Real parts denoted by what? RIMZ and pure imaginary denoted by what? IMZ. We still explain about the application of the complex number and application of complex number in a real life. After then, we proceed on what the concept, that is the addition and the subtraction of what? Complex number. When you bring a complex number and you bring another complex number, if you add them, it will produce a complex number. When you bring a complex number and bring another complex number, if you subtract them, it will also produce what? A complex number. So when you go back to our previous class, you will see the proof of what? Addition and the subtraction of complex number and the examples of the complex number. We still go on and they teach about evaluation, how to evaluate the power of I of what? A complex number. Like to evaluate something like I power 10, I power 30, I power 100, I power 500, etc. All these things. So in engineering, we are using J. In engineering, we use J. J power 10, J power 30, J power 1000. So in engineering, we use J. But in pure mathematics, we use I. They are the same thing. You will see somebody will write it that the complex number is denoted by Z is equal to X plus I, Y. Where S is the real part and Y is what? The imaginary part. Engineering students write their own like this. X plus J what? Y. They are the same thing. Engineering is making use of what? J, while the pure mathematics is making use of what? I. And that is the only difference between them. So in case you see it somewhere X. And sometimes we see some textbook writing that complex number Z is equal to what? A plus what? IB. Some textbook will say is equal to what? N plus what? IM. They are the same thing. So because the one that we are using here is that Z is equal to what? X plus what? I what? IY. All these things is a set of what? Order pair. A set of what? Order pair. They are coming from what? Integers. And that is it. So anyone, you can make use of them. You can make use of two alphabets, but it must be a set of order pair. Thank you. Okay. But today we are going to look at, we are through with what? The addition of complex number, subtraction of complex number, the power of I of a complex number. Today we are going to look at what we call multiplication of what? Complex numbers. Yes, when you bring a complex number and you bring another complex number, if you multiply them, if you take their product, it must produce what? A complex number. And that is the only explanation of what? Multiplication of what? Complex number. If you bring two or more complex number together, if you multiply them, you must produce what? A complex number. Yes. Okay, today we are going to look at the proof. They told us that given that, from the question on the board, given that Z1 equals to X1 plus IY1 and Z2 equals to what? X2 plus IY2. Now the proof say, prove that Z complex number is equal to the sum, what? The product of two complex number. So that complex number is equal to the product of two complex number. And that is what we are going to prove. Did you get it? Are you okay? Are you okay? So should we write on? Okay, thank you, thank you. Now let's start with proof. And in mathematics, we use this type of proof. We use it for asking questions. Like if you want to ask something, you use this type of proof. Say prove that this is it. But if you want to provide solution, we use this one for what? Solution. This type of proof for solution. So now let's go. Z equals to x1 plus iy1 multiply by z2, which is x2 multiply plus iy2. Close it. Now how do we do this? With this we continue. Bring x1 into what? x2 plus iy2. Close it. Plus iy1 into what? x2 plus iy2. Close it. So now when we solve this, what do we get? We are going to multiply this out. We have x1 times this, we have x1, x2. x1 times this, we have this in as x1 iy2 plus x times this x before the y, which we have it as what? x2 iy what? 1. Now I times I will give us what? I square. y1 times y2 will give us y1 y2. Now let's go. Okay, let's collect like them. Always recall from the concept of complex number. Recall that what? I square is equals to what? What? Minus 1. So you always remember this. As a matter of that, what we have now is that z is equals to x1 x2 plus, there is a present of I here and present of I here, so bring it out, bring one I, factor one I out. I into, what do we have here? x1 y2. What do we have here? Plus x2 y1. Close it. Now what do we have here? Plus I is equal to what? Minus 1. Close it. Into y1 y2. Okay. Now what do we have? Z is equal to x1 x2 plus I into x1 y2 plus x2 y1. Close it. Minus times this will give us a minus y1 y2. I hope you are getting it. I hope you are getting it from here to here. Okay. Now, what do we do again? We collect what? Like terms. And the like terms here is those real number to real number. Real number are those numbers without what? I. And imaginary are those one with what? I. So collect real number to real number and imaginary to imaginary. So what do we have? That z is equal to x1 x2 minus y1 y2 plus I into bracket x1 y2 plus x2 y1, and that is 3. So finally what do we have? We have that this is what? Ring z. Ring what? Z. Y here is what? We have this in as what? Z. So where our ring z is equals to x1 x2 minus y1 y2. And our mz equals to what? x1 y2 plus x2 y1. And that is how to prove complex number. So summation of multiplication of two complex number, we give itself what? Complex number. You can agree with me that at the end of this proof, we will be able to get real number, real part, real z, and what? Imaginary. And they say that the definition of complex number is what? The summation of real part, real z, and what? Mz. So when you add z and mz together, you get what? A complex number. So when you prove after multiplying two complex number, you still succeeded in getting what? A complex number. And that is how to do it. I hope you're okay with it. Okay, thank you. Now we are going to put it in a mathematical way. Let's just find an example and solve and see how the thing goes. Thank you. Are you through here? Are you done? Okay. Okay. Question 1. Given that z1 equals to 2 plus 3i and z2 equals to 4 plus I. The question says now find or evaluate that z equals to z1, z2. What do? We start with what? Solution. So z is equals to what? 2 plus what? 3i multiplied by what? Z2, which is what? 4 plus what? I. Close it. So now what do? 2 into what? 4 plus I. Close it. Plus 3 into what? 4 plus I. Close it. What do we have here? 2 times this will give us what? 8. 2 times I will give us what? 2i plus 3 times this will give us what? 12 what? I plus 3 times I will give us what? 3i squared. Okay, let's go to okay, always recall that I squared is equal to what? Minus 1. So we substitute it here. So what do we have here? That z is equal to 8, 12, 2i plus 12i will give us what? 14i plus 14i plus 3 times what? Minus 1, which is what? I squared. Finally, z is equal to what? 8 plus 14i minus 3. Now this is equal to z is equal to what? 8. Collect the like term. The number without what? I together, which is 8 minus 3 plus 14i. So that z is equal to what? 8 minus 3 will give us what? 5 plus what? 14i. So and that is our answer. Hence, ring z is equals to 5, while mz is equals to what? 14. The coefficient of what? I is mz. The coefficient of I is the imaginary one, and the coefficient of I here is what? 14. So which is what? The y. So our x is equal to what? 5. while our y is equal to what? 14. And that is how to solve it. That is how to solve anything concerning multiplication of what? Two complex number. You can see some question multiplication of what? Three complex numbers. They will give you like z1, z2, z3. So you multiply z1, z2. The answer you get, the result you get in z1, z2, you must use the answer against the z3. And that is how to do it. If it is z1 to up to z4, you will now multiply z1, z2, multiply z3, z4. The result you get from z1, z2, keep it. Get z1, z3, z3, z4, keep it and multiply it together again, and you get it. So multiplication of two or more complex number must give you what? A complex number. And that is how to do it. Thanks and God bless you. Remember to subscribe to my YouTube channel, Prismatics Online Class. God bless you. Bye.